So ultimately, how are the intensities estimated? It's basically now dependent on a combination of satellites and recons. So here is an example of the satellites that are combined. Typically, if you have geostationary satellites that are focused on a particular pace because the country is trying to do its weather forecasting using such satellites, then it's easy to track the satellites the whole life cycle, except the blind spots in the middle of the ocean where no geostationary satellite may be covering it. So here are some examples. Tropical cyclone satellite observations from the Tropical Rainfall Measurement Mission Precipitation Radar, which that mission is now morphed into something called GPM, Global Precipitation Mission. TRIM microwave imager and visible infrared scanner. 3D radar reflectivity from TRIM precipitation radar, Aqua EOS infrared, and CloudSat reflectivity profile, the red line in C. So here, okay, so this cross section is seen here for CloudSat reflectivity through Tropical Storm Gordon on September 16, 2006. So that time all these satellites were alive. There are also scatterometers which can give winds, altimeters which can give sea surface heights and heat content, for example, and of course the aircrafts, as we said. The method of estimating them was derived in the 1970s by Dvorak. It's called the Dvorak method of estimating intensities using satellite IR estimates. So it looks for eye pattern, curved band pattern, shear pattern, and central dense overcast pattern. So CDO, central dense overcast pattern, and basically wants to estimate the temperature difference across the eye to the outer region. Gives you a sense of the intensity, of course. So you can see the sample identification of the Dvorak eye wall pattern. Subjective curved band pattern, so it's kind of using the images to draw lines, so it's not a very objective algorithm in that sense, and of course the central dense overcast pattern. Okay, so those are combined to use some algorithm, and it's now automated. So here is the summary of the Dvorak Atlantic and Western North Pacific wind pressure relationship. So this is cyclone intensity, this is mean sustained winds in knots, and this is the mean sea level pressure in hectopascal, Atlantic and West Pacific. So you can see the intensities. Let me see, I make sure that CI is in fact yeah, it's just the wind pressure relationship. Okay, so you can see, let me stop that and make sure I got the CI. Okay, sorry, the CI is current intensity. Okay, so that gives you a sense of how multiple data are combined to define, and there is a basic decision tree that's used. Find the cloud system center, which is the point towards which the cloud bands spiral in. Center location is fairly easy if the low-level circulation is exposed. Otherwise, the center is identified by other features such as the cirrus outflow, animation, or extrapolation. Make two quasi-independent estimates of the intensity of the tropical cyclone. Assign a tropical number T, or which is related to storm intensity, as we saw in the figure. Choose the best estimate, and then apply selected rules to determine the final intensity. Obviously, some experience and some empirical approaches are involved, some subjectivity is involved. So locate the system, estimate intensity, T number, model expected T number, cloud system measurements, I, curved band shear, and CDO. and from the model you have 24-hour changes, pattern adjusted model T number, pattern recognition. So here you are combining data and the model to choose the best estimate, apply the constraints based on the Dvorak algorithm, get the T number again, and go out with the forecasted final intensity, or the publicly announced final intensity. This can cascade into all sorts of other things like insurance, damage estimates, insurance claims, and so on. Okay, so 4 primary patterns and typical T numbers for the range here of curved band shear CDO, banding I, and the pre-storm tropical depression, tropical storm, and hurricane. So this is the various information that go into tropical intensity range estimates. So here are the IRBD enhanced images of a tropical cyclone in Lala, with central pressure of 994, 984, 967, and 927. So originally there is not a very well defined I, but at some point you can see there is a low, of course, but then eventually the I gets formed as the pressures obviously drop pretty sharply from 994 to 927. That's a very strong drop from 11th to 14th March, because the pressure gradients correspond to the maximum strength of the winds and of course the intensity of the tropical cyclone. The Dvorak method has been updated. Now this is advanced Dvorak technique compared to the older objective Dvorak technique for Hurricane Ivan 2004. So here are the various days and times, and you're going from here to there, and the blue numbers are the objective Dvorak technique, and the red numbers are the advanced Dvorak technique, and there is recon numbers listed as well. So if you compare the numbers where all three are present, recon says 964, ADT is closer to it, but the older one is off by much more, and the same thing happens here. This difference is even larger. So obviously the advanced Dvorak technique has improved the estimates of the eye wall pressure, and hence the intensity of the cyclones as well. And you can see here the estimated category, tropical depression here, tropical storm over this white line. You can see nice images underneath. Becomes category 1, 2, 3, 4, and then 5 here, and then goes back down. So here it vacillates a little, 5 to 4, to 5 again, 4 again, 5, and then so this is what we were talking about, the intensification, inertial stability, upper level flow, sea surface temperatures, and so on. Because it's going over a range of islands here, the energy supply can change, cyclone speeds, translation speed can change, its intensity can change, size can change. You can see that the size is much tighter here, and then it becomes larger as it approaches land over here, over basically almost 2 weeks, 2nd September to 15th September. So that's the way in which tropical cyclone intensities are estimated and forecasted. Well, actually these are from data, so they are ultimately determined to be of that intensity once the cyclone is done with its life cycle. And it's very critical to know that when it's approaching land, because if New Orleans is getting a tropical cyclone category 2 versus category 5, the preparations, the amount of protections to be given, number of evacuations, everything depends on the category. So people, for example, may choose to ride out a category 2 storm, but I think category 5 will give orders for people to evacuate as opposed to giving them an option, for example.